All right. Hey, everybody. It's great to see some familiar faces and a couple new ones. Wonderful. I love all those stars, Nyla.
Thanks. I don't think I made this background.
Oh, it's very cheerful. Very happy. All right. It is great to see everyone. Did you guys all have a good summer? Are you ready for summer to be over? Ready for the heat to be over? All right. I'm always ready for the heat to be over. All right. There you go. All right, Wick, if you want us to call you Wick, you should type Wick in there. You said that in your message that you would prefer to be called Wick. There you go. Yeah, make sure that you have your name as you want me to say it typed into the chat box. We'll talk about how to pronounce names when everybody gets here. We have a few more students in class. Yep, there you go. There you go. All right, let me arrange a couple things here. Anybody have any questions before we get started? You've had a couple days worth of lessons. Remember that the days that we don't have a live class, you do have actual work. You do have lessons that you want to do, that you'll need to do. So, okay, I'm going to go ahead and get us started. Let's see here. They changed Canvas on me over the, there we go. That'll do. All right, I'm going to share my screen with you so you can see what I'm looking at. This is Physical Science 1. We will study matter in the first half of the year, and then the second half of the year we will do energy, kind of. I mean, there's a little overlap, of course, in those topics. So we'll have a little bit of overlap. I'm Dr. Joseph. Very nice to meet those of you that I haven't met before. And I'm looking forward to taking this journey with you to learn all about what the universe is made of. So a few of you wrote down in your introductory assignment that you were excited to learn about matter and to learn about molecules and atoms and those kinds of things. So that's definitely what we're going to do. We're starting out the year. So before we dig into talking about what matter is, I have just a little bit of information that I need to go over to make sure that we're all on the same page with the use of Canvas and how I run my course. It's a little different than the way other teachers might have theirs. So the first thing to remember is if you are new to Canvas, if you haven't used either AIM Academy or Canvas in the past, make sure that you watch the tutorial video that I put in the classroom resources section. I don't want to take time today teaching you how to use Canvas. You can learn that by watching the video, and you'll get to the video by right on our homepage. It looks like this. There's this classroom resources section. If you click on that, it will take you to a page that looks like this, and right at the top there, how to navigate in Canvas. Just make sure that you do watch that. Another thing to keep in mind is at the top right of the page, when you're looking at a lesson, it says Immersive Reader. There's a little link that you can click on. That Immersive Reader will read the text on the page to you. Now, it only shows text. It doesn't show pictures. It doesn't show videos. It's just the words. So you might want to split your screen or, be listening to it while having another screen open so that you can look at the pictures, because sometimes the text describes them. Now, also, you'll notice if you've been in the lessons yet, I have a lot of recordings of me narrating those pages for you. You can use those if you want to, but you don't have to. Basically, you have two choices for narration, or you can have no narration at all if you prefer to just read it yourself. That's completely fine. So I also want to remind you guys all, thank you for having your webcams on. That's awesome. We always have to at least start class with webcams on. That's an AIM Academy safety policy. So always at the very beginning, you need to make sure you have it on. I prefer that you leave your cameras on the whole time, because that's how we get to know each other. It's how I get to know you. And there may come a day when you want a recommendation or a reference from me. If I know you, if I've seen you and you've come to class and you've participated, then I'll be able to help you more than if I don't know you at all. A couple of other important bits of information. I know I'm flying through this, but I don't want to spend a lot of time on this stuff. Always make sure that you work your way down the assignment list. When you're looking at the assignments page, you'll see they're in a line. Well, they build on each other. So don't jump around. Don't say, oh, I think I'm going to learn about acids and bases before I learn about molecules. That won't work. You need to make sure that you do them in order. Use good spelling and grammar in your assignments. Right now, I'm not taking off points for that, but eventually I will. I'll talk to you about it first, though. Make sure that you always click your submit button when you are sending in a quiz. If you get all the way to the end of a quiz and you just leave without clicking the submit button, your work is lost. So you don't want that to happen. And please contact me if you have any questions or concerns. If your questions are about the lessons or the quiz, contact me before you submit the quiz. A lot of those quizzes are computer graded, and once you submit them, they give you the correct answer. So once you've clicked the submit button and submitted the quiz, I can't then give you credit. I can still help you, and I'm happy to do so, but I can't go back and give you credit. If you contact me before, then I can. All right. Let's talk a little bit about AI. So AI stands for, well, anybody know what does AI stand for? Nyla.
Artificial intelligence.
Right, artificial intelligence. So you can think of AI as being an expert that's sitting right beside you at all times and can help you with whatever you want to learn more about. Now, you have to be over the age of 13 to use it. So if you're 13 or up, you can get parents' permission. If you're under 13, if you're still 12 or 11 or 10, you can't use it at all. That's just kind of the AI rules. If you are going to be using it, there's a way to use AI to help you, and there's a way to use AI to hurt you. And that's true of most technology, right? Cell phones are great, but they have some disadvantages as well. So AI can help you to understand something a little bit better, something that maybe you don't completely understand. Like if I were to say, what's the difference between a proton and a neutron? Maybe you've never heard the word proton before. You can go into an AI program and say, what's a proton? And it'll explain it to you. What you don't want to use AI for is to help you, to give you answers. You don't want to copy and paste anything from ChatGPT or any other AI program. That's not honest. That's not integrity. That's called plagiarism. And it will get you thrown out of a college class or fired from a job if you plagiarize. So my job is to help you to learn how you can use AI in an honest and meaningful way, and how you can avoid using it in a way that isn't honest. Now, not only AI, but also other copying and pasting is against the law. It's against AIM Academy policy. It's against good judgment. So if I suspect that there's any copying and pasting, I'm going to contact you and we'll talk it through. Okay. I want to help you learn what's copying and pasting, you know, what is honest and what is not. So we have a new program in Canvas now to help with this, because students a lot of times say, Allison, well, that you're not Allison. Are you Allison? Yeah, you are. All right. Sorry. So yeah, students don't always mean to plagiarize. They don't always know for sure what plagiarism is. And students don't always know that it's not okay to just copy and paste something from a website or an AI program. So we have this program called Plagiarism Check. Now it's brand new. We've only had it for a couple of weeks. We haven't really worked with it yet. This is something that will allow you to check your own work before you submit it, or rather in between submissions. So whenever there's written assignments, like let's make it real, good example. Let's say you have a test and the test has 6 questions on the test and you write out your answers. You submit that, and then you'll get a report from plagiarismcheck.org, and it will tell you how much and what of your paper may have come from somewhere else, may have been something that you copied and pasted. You can then go in, correct those questions, make them your own, and then submit it to me. And I grade your second attempt, not the first one. The first one is a learning opportunity. The second one is the actual assignment that I will grade. So what happens if if it says, oh, you plagiarized this answer, but you say, no, I didn't. We'll have a dialogue. I'm not trying to trick you. I'm not trying to find a way to take points away from you guys. I want to help you. That's my goal. So I'll help you. We'll talk things through, and then we will see, we'll come to a decision together. There are some things, like if I said, what are the parts of an atom? I mean, there's only so many ways that you can say proton, neutron, and electron, right? That's going to be flagged as being plagiarized, even though it's not, because it's out there somewhere in the exact wording that you used. So we'll get there. We'll talk it through as we use this more. It's kind of an experiment for AIM Academy to use this. As we use it more, then we will, we'll reevaluate and see how it's going. I would ask you guys to help me as you find things in the lessons that may be wrong. They may be an error, might be a typo, or, I forgot to click the right answer in one of the quizzes. Please let me know. Don't think to yourself, oh, I thought my answer was right, but it got marked wrong, so it must be wrong. Contact me and say, I think my answer was right. You may be correct. You may be right with that. I want to talk a little bit too about due dates. So in my classes, the due dates are important, but they're flexible. That means I don't take off points for anything submitted after the due date. I give you time. I would rather that you took your time, took an extra day or two if you needed to, and turn something in after the due date than that you rush and not do a good job, not do it well. So why do we have due dates at all then if they don't matter? Well, they do matter. They are important, and they're important for a couple reasons. The first reason is because it keeps you from falling behind. You know how it feels when you have too much to do and you get real stressed out and you think, I'm never going to be able to do this? I'll answer that in just a second here. You don't want to get stressed out. So I don't want you to fall too far behind the due dates in getting yourself stressed about it. The more important reason, I think, is that these live classes that we have are related to what you're learning about. As an example, in a couple of weeks, you'll be reading about the periodic table of the elements, and we'll be doing some work here in class that's related to the periodic table. If you haven't read the lesson, then the class isn't going to be as meaningful to you. You won't understand what we're talking about. So staying with the due dates will really help you. Now, you don't ever have to write and ask me for extra time. Somebody just said, I didn't check the assignments. Can I have an extension? There's no need for extensions in my class because I don't take off points for turning in something after the due date. You've got as much time as you want to do it. And I recommend that you stay with the due dates, but I don't punish you if you don't, if that makes sense. In fact, I give you a little bit of extra credit if you do. I give extra credit for assignments that are turned in by the due date. At the end of every semester, before I give you your grade, I'll go back and I'll count the assignments that you submitted by the due date or on the due date. And I give you 1/4 of an extra credit point for each of them. Now, we've got 16 weeks in a semester, and there are 4 lessons every week. Every week. So that could be a whole point every week. That could be 16 points that you get extra credit. That's enough to bump your grade up from a B to an A or a C to a B. So it's worth it. It's definitely worth it to turn those assignments in by the due date in order to get that extra credit, if for no other reason than that one. Another thing that I bump your grade up a little bit on is coming to live classes. I do keep track of who comes, and I keep track of who participates. So if you come, your grade will be bumped up just a little bit. And if you participate, your grade will be bumped up a little bit too. All right. Now, we use polls a little bit in Zoom from time to time. A poll is just an anonymous quiz question. I'm going to show you one. I have one ready just to give you an idea of what it looks like to take a poll in Zoom. So you should see that there. I would rather, and you click your answer, whatever you pick. I'd rather visit the bottom of the sea, visit the center of the earth, visit another planet, or visit another solar system. So as soon as everybody has given their answer, then I'll end the poll and share the results with you. But it's all anonymous. Nobody sees what you wrote down. All right, excellent. Everybody answered that. We don't have anybody who wants to go to the center of the Earth or to visit another solar system. We've got an almost even split with bottom of the sea and another planet in our solar system. So that's what a poll looks like. We'll do a few of those as the year goes on. All right. I want you guys next week, if you can, to bring some supplies to class. So once in a while, I'll ask you to do that. This next week, so next Wednesday, I'd like you to bring 1.5 cups of cornstarch, a bowl, a spoon, a cup of water, and some paper towels. You don't have to write this down. I'll send this to you. I'm going to send an announcement by the end of the day today. I'll send an announcement to you to gather those supplies. If you can't get the supplies or you forget, it's fine. You could always just observe when we do our activities in class. I just always think it's better if you actually do participate. So taking a look at that stuff, anybody know what we're going to do with those things? What are we going to do with cornstarch and water? Nyla?
We're gonna make oobleck.
Yeah, we're going to make oobleck. So oobleck is sometimes called non-Newtonian fluid. Somebody said yesterday that they heard it called cornstarch mud. That's kind of a good term for that one. But oobleck is a substance that sort of defies the solid liquid rule. You know, sometimes it's solid, sometimes it's liquid. It's solid under pressure. Like if you slap it, it's real solid. But as soon as you release it, then it's liquid and it goes to liquid. It's fun to play with. And we're going to do that next week when we talk about solids and liquids and gases. All right. So to that end, from time to time, I will ask you to bring supplies to class. And I'm going to show you how you will know that. Every morning I send out, every morning before class, I send out an announcement that tells you, that reminds you that we have class and tells you what to bring. So here, I'm going to show you this right here. This announcement's right here. There, if you click the little one, there'll be a number right here to tell you there's a new announcement. If you click on that announcement, it will tell you Physical Science Wednesday section right here, and read through that. This one says, for today, bring something round to class. It can be anything, flat or 3D, as long as it's round. Now, if you didn't get this message to your email, it means that you didn't validate or verify your email address. You need to always make sure that you do that. So that you get these not only to Canvas, but also to your email. So right here where it says the modules or assignments, right here it says urgent, please watch this video to confirm your email address. Please make sure that you've done that. You don't want to miss out on anything important. Okay, so that's fine. One of you just said you're not going to make it next week or going on vacation. That's fine. I always post the recordings of the live classes so you can go back, see what we did. You can watch the recording and then you can either participate along or not, depending on what works, whatever works for you. All right, let's close this off. All right, anybody have any questions about the business part of the things that we had to cover? All right, I'm always here if you do. Contact me if you have any questions. All right, let's talk about matter. Now, matter is the stuff that everything in the universe is made up of. It's made up of particles that we call matter. Matter has characteristics, and some of those characteristics can be directly observed and measured, and others can't. So if you brought your round object, either your 3D or flat, could be just a circle on a piece of paper, that would be fine. Now's the time to get it out. All right, let's come up with a few characteristics of your round object that can be observed and measured directly using your eyes or your other senses. So when I look at this one, you can use mine if you don't have one of your own, that's fine. Give me some characteristics of this one. Also, one thing I wanted to show you guys, make sure when you're chatting, when you're sending a message in chat, if it says just to me, if my name is in that blue square right there, that means it's only coming to me. If you want to send to everybody in the class, then click the everyone in meeting button. Yeah, okay. All right, so the direct message means it went just to me. All right, so we've got size, feel, color so far. So Cheyenne, is that the right way to pronounce your name?
Yes.
Okay, good. So you're just sending directly to me. If you want everyone to be able to see it, click the down arrow and choose everyone in meeting. Because if you have an answer, you want to get credit for your answer, right? All right, yeah, it has holes in it. Yep. So we have size, color, shape. It does look squishy. And in fact, it is. It's one of those stress balls that you squeeze. So it is squishy. Anything else you guys can think of? It's kind of bumpy. It's got some surface features. It's not real smooth. It's round. Yep. There are some things that we can measure. We can measure how wide it is. We can measure the circumference or the distance around. Yep, the weight. We can measure the weight of it. Good. We can measure the radius. Absolutely. The radius and the diameter. So radius is halfway across. Diameter is all the way across. The volume, we can measure the volume. One of the ways that we would measure the volume of something like this is by dropping it down in a bowl of liquid and seeing how much the water went up. That's a way to determine the volume of something that's not perfectly square. It looks heavy for its size. It's actually very light. It does kind of look it, but it's very light. Yep, there you go. There you go. All right, let's talk now about some characteristics that cannot be directly measured. All right, somebody wants to say hello. She just jumped up on my lap so she can say hi to you guys. This is Maya, and she sometimes likes to sit with us when we have class, so you'll see her from time to time. Any of you guys have pets? Yeah, they let you know what they want, that's for sure. That's for sure. All right, you have to sit down here though. Good girl. All right, so let's talk about the things, the characteristics that you cannot directly measure, that you cannot directly observe. What do you think? I can't directly measure or observe what it's made of. I can't tell what the chemicals are that went into making this. And I can't tell what it's like on the inside. I can't see in there. It is definitely made of atoms, but I can't see those atoms. Right? Yeah. So there are some things on the inside of this that I cannot directly observe. I need to use tools in order to be able to observe the things, indirectly observe or make judgment calls about, make a hypothesis about. So now think about the study of the universe. Let's boil it down to the earth. Think about the earth, the things that we can observe and measure about the earth. What can we directly measure and directly observe about the earth? Yep, the size, the diameter. What else? Circumference. Yeah, we're measuring the same, we're describing the same things again. Basically the same things that we observed and measured about our ball, we can measure and observe about the earth. And the same things that we cannot measure and observe about our ball, we also can't. We can't look inside the earth and know what's in there. We can't look at an atom and know what an atom is. We can't look at a substance and know what atoms are in that substance. So some things we can directly observe, other things we cannot directly observe. And we'll talk about both because both are what we call matter. So what we're going to learn about matter in the lessons that you read this week. So when I use the word matter, what I mean is the stuff that everything in the universe is made of. So matter is composed of particles. What's the tiniest particle of matter called? What is the tiniest particle? Yeah, good, Wick. It's an atom. An atom is the tiniest particle of matter. Yeah, Cheyenne, you got that one too. Very cool. So I like it when you guys talk. If you want to type, you're welcome to, but I like it when we have more of a conversation. So feel free to do either, whatever you're most comfortable doing. So matter is made up of these tiny particles called atoms. When those tiny atoms combine with other atoms, we call the new thing that they formed something. What do we call it when two or more atoms bond together? When they attach to one another chemically? What do we call that? A chemical reaction is what takes place to form some things. Nyla.
A molecule?
Yeah, an atom and is just one, two or more bonded together is going to be a molecule. Excellent. All right, I have a couple of cartoons about matter. I do like in my classes to sometimes bring in cute cartoons or jokes or riddles or things. So if you guys know any good physical science jokes, physical science riddles, please send them my way and I'll make sure that they get into the live classes. All right, so here's one. When you ask a science teacher, what's the matter? What does she say? What's the matter? Everything. Everything is made of matter. So everything is matter. All right, here's another one. You guys know the difference in an optimist and a pessimist? An optimist is somebody who looks on the bright side. A pessimist is somebody who's kind of negative about things. If an optimist looks outside and says it's raining, sees that it's raining, they might say, oh, good, the flowers are going to get some water. The pessimist is going to go, oh, no, I hate rain. All right, that's the difference. Well, an optimist looks at this glass and sees the glass is half full. The pessimist sees the glass is half empty. But a scientist sees that the glass is completely full, half in the liquid state and half in the vapor state. It is technically always full. And how about this one? Well, why can't you trust atoms? Why can't you trust them? Because they make up everything. Yep, you never know when they're making something up, right? All right. Yeah, you have that to look forward to a lot of the weeks because I like jokes. I like to laugh. Anything that makes me laugh is going to go into our class. All right, let's kind of stop for a minute and think about what we already know about what we're going to be learning. You'll be surprised that you already know a lot about what we're going to be focusing on this year. So when I say physical science, when I use that term, what do you think of? Anybody? Allison.
Like learning about the like physical parts of the earth.
Yep. Excellent. Chemical reactions, molecules, anything physical. Yep. You're sending that just to me again. Nyla.
Atoms and stuff.
Yep. Atoms and molecules. Yep. Stuff is a good term, Nyla, because really when we're talking about physical science, we're talking about the stuff that makes up the universe, right? We're talking about all the particles. Matter refers to all the stuff that makes up the universe. And physical science basically has two parts to it. AC.
The parts of science that you can see?
Well, yes, there are parts of science that we can see. Physical science also, though, has to do with parts that we can't see, right? So it's not just what we can see, it's actually both the seen and the unseen, because physical science has to do with matter. And in some way we can see matter. Even when we get down to an atom, we have tools, we have equipment that allows us to be able to visualize atoms. And then, of course, when we've got larger things, we can see those. But physical science also includes the study of energy. We can't always see energy. There's a lot of energy flying around the air now, and we can't necessarily see that. But it does include the things that you can see and even the particles that you can't. Like the air right now, the air around you, you know, you can look at it. You can look as long as you want. You're not going to see all the atoms and molecules that are in the air, but they're there. We have ways to prove that they're there. So physical science in a nutshell is matter and energy and the study of those two things. Everything that is made up of matter, anything that has energy, that's what we study in physical science. And we can divide physical science into four main groups. So let's look at those four main groups. We have this one here, chemistry. We're going to learn a lot about chemistry and chemicals in this class. Chemistry is the study of matter and energy down at the atom and molecule level, where we're talking about how they interact with one another. So chemistry can really help us to understand the world around you, because the world around you is chemicals. Your chemicals, your body is made up of chemicals. Everything that you can taste or touch or smell is a chemical. And chemical reactions are the reason that we have so many different things in our universe, in our world. We'll also learn about physics. So physics is the study of matter and energy from the tiniest particles of matter all the way up to the entire universe. So physics helps us understand just about everything in the world around you, again, because everything is made of matter and has energy. Physical science also includes a bit about earth science and a bit about astronomy. We don't really go into that too much. We're going to spend most of our time this year talking about the physics and the chemistry in physical sciences. All right, have any of you guys heard of the scientific method? Have you used the scientific method before? Yep, good, good. All right, let's talk about some terms that relate to the scientific method. What words do you think of when you hear that word, scientific method? Anybody? Nyla?
All the different types of tests, the lab
Yep.
tests, the field tests.
Yep, excellent. Hypothesis, yep, that's a good one. Anybody else? I'm gonna analyzing, yeah, that's a good one. I'm gonna annotate here. Let's put that in there. So when we use a scientific method, the first thing we look at, the first thing we do is observe, right? Observation or observing. Yeah, very good. Then we ask a question based on our observation. Then we write our hypothesis. Then we do an experiment. We gather data. We draw a conclusion. And we present our results. That's the steps of the scientific method. We'll talk about those as we go through the course. I'm not going to spend a lot of time on it right now because we'll get to it as we're moving through the course. Now, we measure things. We measure matter. We have different ways to measure it. What are some words? Can't make this go. There we go. Oh, let's delete that. There we go. What are some words that have to do with the way we measure? Think about how you would measure something that was long. You know, how would you measure a long piece of string? Nyla?
With a ruler.
Yep, a ruler, a yardstick, a meter stick. How would you measure how much something weighed? Yep, you might use a scale or a balance. Good. Anybody know what this is? What this thing's called? That's called a graduated cylinder. Yeah, so this is a beaker. Right here, this is a beaker. I don't know if you guys can see that very well. Maybe I can hold something up behind it. There we go. Right there. So that's a beaker. And this is a graduated cylinder. And this one of my favorites. You know what that's called? This one is called a flask, or actually an Erlenmeyer flask, because the guy who designed this, his last name was Erlenmeyer. So he named it after himself. It's an Erlenmeyer flask. So those are ways that we measure liquids. We use graduated cylinders, beakers, and flasks to measure volume, to measure the volume of a liquid. So volume is another term that is related to scientific method, scientific measurements. All right, how about this one? How many terms can you list that relate to matter? So we've been talking about those the whole class. Just tell me some of the words that I've said before. Atoms, molecules, Science. Yeah. So matter comes in a couple of different phases on Earth. Gas is one, physics, good. Solid is another, negative and positive. Liquid is the third. Yeah, there's a fourth phase of matter. We don't have much of it here on the Earth. Anybody know what that fourth phase of matter is? Solid, liquid, gas, and Nyla?
Plasma?
Plasma, yeah. So stars are made of plasma. So because there's so many stars in the universe, plasma is actually the most common state of matter in the universe. We just don't have much of it here on the Earth. So that's why. Dark matter, good. Good. Matter can also change from one state to another. What do we call the process that takes matter from being solid to being liquid? Think about an ice cube. What's the process called that takes something from being solid water to liquid water? Melting. Yeah, melting. What process takes it from being liquid to being solid? Freezing. Excellent. What takes it from being liquid to gas? Heating or boiling. Yep, both of those would be good answers. What takes it from being, anybody know this one? Sometimes in your freezer, you open your freezer up and your ice cubes have gotten really tiny. That's because they've gone directly from being solid to being gas without going through the liquid state. That word hasn't, that process has a name. To go from solid all the way to gas without becoming liquid in the middle. That's called sublimation. Sublimation. Yeah. So those are all terms that have to do with matter. And of course, matter is made up of atoms. So tell me what the parts of an atom. What are the parts on the inside, these blue and red? Dry ice is a little bit different, AC. Yes, dry ice is carbon dioxide that goes directly from the solid to the gas. So yes, it's not, the process is not sublimation though. It's a little more complicated than that, but you're right. Okay, so protons, neutrons, and electrons. Yeah, so what's in the middle? What are the red ones and blue ones? Protons and neutrons are in the middle. So it doesn't really matter what color they've made it here. Protons are, so let's say the protons are red and the neutrons are blue. Then what are those yellow ones on the outside called? Those are electrons. Why do they have it, that little negative sign in there? Why do electrons have a little negative sign when we picture them like that? They have a negative charge. Excellent. Look how much you guys already know. There haven't been many questions that I've asked you that you haven't already known the answer to. So electrons have a negative charge. What charge do you think protons have? Protons. Yep, protons are going to have a positive charge. What are neutrons? What charge are they going to have? 0. Yeah, they don't have any charge at all. They're neutral, meaning they're not positively charged, they're not negatively charged. And that all matters. That all is important. The fact that those electrons are negatively charged really matters. It's really significant. That's why the things behave the way they do. All right. Now, anybody know what the word element means? We talk about the periodic table of the elements, and we'll go into some detail about that in our course. What is an element? Pure matter. Good. You're on the right track. A group of atoms. You're on the right track. Well, it's more than usually one molecule, but it could be one molecule. If we put all those together, a group of atoms of one kind that are pure and have nothing else in there, that's what an element is. So if you have a group of, say one or more oxygen atoms, that is the element oxygen. As soon as you add hydrogen to it, now it's not an element anymore. Now it's a molecule. It is water, hydrogen and oxygen. If you've got a bunch of copper atoms, even 2 copper atoms, 1 or 2 copper atoms, that's all you have, that's the element copper. Can't be broken down anymore, right? It's down to its purest substance. Excellent. Let's name some terms, name some elements. Not Disney elements. I just thought that was a cute picture. Iron, yep. Bet you know a lot of them already. Copper, gold. Oxygen. Hydrogen. Zinc. Sodium, iridium, mercury, plutonium. Excellent. You guys are naming some common ones and some more uncommon ones. There's only one element that starts with the letter K. Anybody know what that is? Only one element that starts with the letter K. Superman doesn't like this one. Krypton. Krypton, not kryptonite. It's close though. Yeah, krypton is the only element that starts with the letter K. Here they are. Here's a list of all of them. Now they're not on the periodic table here. They're just simply listed by size. So you can see their hydrogen is the smallest of all the elements, and oganesson is the largest of all the elements. Now most of these big ones over here are not found naturally in nature. They're made in a lab, and they're so big that they're unstable. That's funny, isn't it, to talk about an atom being big? But it just means it has so many protons in its nucleus that it's not stable and it breaks down very quickly. They only exist for a fraction of a second. All right, so you guys know a lot. You've already discovered quite a few things in your studies that you've done so far. And, you know, we're going to learn more. We're going to learn what all these are. We're going to discuss this thing in the next couple weeks. So we have this table that somebody has put together. We'll talk about the history of the periodic table, but we put this together in a way that helps us to understand, that makes a lot of sense. We can divide the periodic table up into groups. There are metals, there are non-metals, and there are metalloids. There are noble gases, there are hydrogens, there are transition metals. The periodic table has groups and periods in it. And all of those will help us to understand how atoms, how elements work the way they do in our world. Toward the very end of the semester, we will talk about Newton's laws of motion. Anybody know them? Anybody know one of them? Cheyenne.
I think it was an object in motion. What was it? An object, something about well, I forgot it.
You're on the right track. What does an object in motion do?
Oh, an object in motion. Oh, wait, I remember the one. If you like, every reaction has an every like action has equal and opposite reaction.
Right, that's his third law. That's the third law. Every action has an equal and opposite reaction. You were about halfway done with the first one. AC.
The first one is an object in motion will stay in motion until something of an uneven force.
Yeah, and unless acted upon by an unbalanced force. Yeah, very good, very good. And at the same time, something that's not in motion will stay still unless acted upon by an unbalanced force. That's Newton's first law. Those two are a little easier. Newton's second law is a little more complicated. FMA is Newton's second law. Anybody know what that stands for? Cheyenne.
Force times I think times mass equals acceleration.
Close. Force equals mass times acceleration.
Oh.
Yeah, but there's a little math involved in figuring out his second law. And we'll get to those. We'll get to Newton's laws before the semester is over. We'll also talk a little bit about forces. We'll talk about some forces like gravity and friction and elasticity and acceleration and projectile motion. I mean, physics is just so cool. And we're going to talk about a lot of these things. And hopefully a lot of this will make a lot of sense to you because matter matters, right? You have to remember everything that you look at is not just the thing that you're looking at. If you had eyes that could see down to the very smallest particles, you would see that everything is made up of those particles. Those particles behaving the way they do is why water acts differently than oxygen does. It was why water, water is a completely different substance than either oxygen or hydrogen, and yet water is made of oxygen and hydrogen. So we're going to be looking deeply into things. We're going to try to look at the individual particles to see what they're made of and to see how they stay together. Matter matters. When we're talking about molecules, we have, this is an example of a molecule. So this molecule is made up of certain atoms. What atoms do you see in that molecule? Nyla?
Oxygen, hydrogen, and carbon.
Yep, very good. How many carbons are there? Cheyenne?
6.
6. There are 6 carbons. How many hydrogens? They're a little harder to count.
12.
12. How many oxygens?
6.
Yes, 6. So take a look at that molecule. That molecule looks like it's flat. It's actually not flat at all. When glycogen is broken down, you get glucose. Glycogen is a kind of glucose that's stored in muscle, so it's a little bit more complicated than just breaking it down. Glucose is what's part of the table sugar that you use. Like if you sprinkle sugar in your iced tea, it's made up of glucose and fructose is what makes up sucrose. So these different sugars combine. But I want to focus on the molecule. It doesn't really look like that. It's not really flat. It's actually 3D. It looks more like that. And it has this ring shape in it. So I have a model here that shows you how 3D a glucose, a simple sugar, believe it or not, this is a simple sugar molecule. We don't want to have to draw this every single time we have to talk about the glucose molecule. So we have a simplified way that we can identify this, and we'll learn about what all those are in our course. We write it like this. This tells us there are 6 carbons, 12 hydrogens, and 6 oxygens in this molecule. Now, in these pictures, the atoms are represented by spheres, but they're not really spheres. If we could get really tiny and look at each of these, they wouldn't be a sphere. In fact, they would look like this. They'd look like that atom. And they would have a nucleus that had protons and neutrons. And then around the outside, there would be electrons. And these electrons are so far away from this nucleus that really atoms are mostly empty space. So if we look at this atom right here, this is an atom that has 8 protons, 8 neutrons, and 8 electrons. It's the atom oxygen. That's what this is. Now it looks here like this nucleus is really close to the electrons. But if we look at the smallest atom, the hydrogen atom only has one proton in its nucleus right here. If we could magnify that hydrogen atom so that it was the size of a basketball, that one electron would be about 2 miles away. The space in between the electron and the basketball-sized nucleus is empty space. So that brings us a question. Everybody take your hands and clap your hands together. Your hand is made up of atoms, and atoms are mostly empty space. So why doesn't one hand go right through the other? If it's mostly empty space, why? Why do they stop each other? Why do you clap? Any thoughts? Remember the negative signs on the outside of the electrons? When we were looking at that picture before, the ones on the outside of the nucleus? Yep, they repel. They repel. So you guys have probably all played with magnets at some time in your life. And you know that magnets have a positive end and a negative end. And if I put them together so that the positive and the negative are together, then they hold on. Right? They attract one another, positive and negative attract. But if I put them together so that the negative and the negative, I can't even force them together. They're repelling one another. It's a little bit different, but in a very similar way, the negatively charged electrons that are in the atoms of this hand repel the negatively charged atoms, electrons that are in the atoms in this hand. They repel one another. This is why you can sit on your chair without falling through, because your body's mostly empty space, and so is the chair, but the electrons of the chair repel the electrons of your body, and you stay on a chair. It's why you can walk around on the floor without falling through. Pretty cool, pretty cool. All right, let me see here. We're running out of time. Okay, we talked a little bit about the states of matter. Wick?
Wait, if the atoms have electrons on them, why do atoms want to combine together?
I'm sorry, you're gonna say that again, a little
If
louder.
atoms have the electrons like on the outside of them, then why do atoms want to combine together? Won't they just
We're gonna learn all about that. That's because atoms have a certain number of electrons that they really want. An atom, most atoms really, really want to have 8 electrons on the outside. If they have 7, they will share with another one so that they can have 8. That is a chemical reaction that happens. Electrons, if they have, if they have 7, they'll share with one. If they have 6, they'll share with one that has 2. So they combine in this electrochemical way in order to be what we call stable. And we'll learn a lot. We'll learn all about that. I don't want to go into too much detail now, but that's an excellent question. Yep. And it also looks like electrons move in these circles like this. They don't. They move in very cool ways. They move in really interesting ways. All right. So like I said, we're going to learn about the different phases or states of matter. You can also call them phases. We'll talk about phase changes. And I think we're going to stop right there. I don't want to get into too much more here. So we'll get to know this guy really well this year, this periodic table. It's a very fascinating and wonderful tool. In fact, anybody, I'll tell you this later when we study it, but anybody who can learn all of the elements on the periodic table will be able to tell everybody in class if you want to, and you'll get some extra credit points for learning all of the elements on the periodic table of elements. Kind of fun. Probably, I think that's week after next or 2 weeks after next. All right. Anybody have any questions for me? Is there anything that we've talked about that you'd really like to, yeah, from memory, Wick. Yep. Is there anything that you've heard of that you really want to learn more about, that you would like to spend more time focusing on? Well, if there ever is, send me an email through Canvas and let me know, because I want this to be your class. I want it to be something that's meaningful to you. All right. Everyone have a wonderful week. Thank you for coming. I will see you next Wednesday. Bye, everybody.
Thank you. Goodbye.
Thank you.
Thank you.
Thank you.